so like I said, we're going back to the beginning. What is an angle?
The bendy parts of shapes. Finger words. Measuring the length.
Yeah, it's pretty close. So we're measuring so the measurements between two what? They're not lines because lines go on forever. They're not segments because segments stop on both ends.
Rays.
They're rays. That intersect at the what? Vertex. That's the point between them. Okay. We have two sides to an angle. We have the starting ray, which is like what we're measuring from, and we call that the initial side. And then we have the ending ray, which we call the terminal side. So if things are coterminal angles, what does that mean? Not quite. What does co mean? Together, or both. And if it's terminal, what does that mean? No, what did we just talk about? The terminal side. So it's two angles that have the same terminal side. So, like, if I had that angle, and I'm measuring from my bottom to the top, my top side is going to be the one that is our terminal side. So then if I had another angle that went that direction, those would be coterminal angles because they share the same terminal side. Does that make sense? Now, the problem is when I ask you to draw angles, we could technically draw them any which way. So like I could draw an angle that goes that direction, but I could also draw an angle that goes that direction or goes that direction. Agreed? Are those the same angle? Like do they have the same angle measurement? Potentially, right? Like if I had drawn them each with a protractor, just because they're facing different ways doesn't mean they're not the same, but it is hard to tell if they are the same or not. Agreed? Which is why we have standard position. Basically, standard position tells us we're going to all draw our angles the same way. That way it's really easy to tell what the angle is. Does that make sense? Okay. So standard position is going to be where the initial side is on the positive is at 0, 0. And it rotates what direction? Counterclockwise. Yes? So a lot of this is just vocabulary. That way we're kind of all on the same page when we try to describe things or write about things, that we know what we're asking about. Yes? Maybe? So most of us should have seen things in degrees before. So what is one full rotation or a degree measure? 360 degrees. Agreed? So what is half a rotation?
180.
Which is also a what?
Half rotation.
It's a semicircle, or that angle would also be a straight line. Okay, and then half of that would be
So right
90,
angle.
which is also a right angle. Okay? Do we have that down? So let's go ahead and graph or draw 130 degrees in standard position. So where did we say our initial side is going to be?
Positive red x-axis.
Positive x-axis. And our vertex is going to be 0, 0, or the origin. Okay, and we said that we're going to rotate counterclockwise. Do you remember how we label our quadrants?
1, 2, 3, 4.
Agreed. But again, we go counterclockwise, and we do label them with Roman numerals. You only have to go up to 4, though. Okay. Don't freak out just because they're Roman numerals. So then we have to decide, going counterclockwise, my positive y-axis would give us an angle of what? 90, because it's a right angle. My negative x-axis would give us 180. So what quadrant is 130 in? The second one. Is it going to be closer to the x-axis or the y-axis? The y. It's actually going to be a little less than halfway. So that would be 130 degrees. When you're drawing these on your homework, I'm not going to get out my protractor and make sure they're exact, right? I'm just going to say, oh, okay, they're in the correct quadrant. They're slightly closer to the y-axis. That's all I'm really looking for. Does that make sense? Okay, so then the question asks us to find a positive and a negative coterminal angle, which means what? What do we say coterminal meant?
They share two angles that share a terminal side.
Terminal side. So remember, our terminal side is the one that rotated. So it's this one on the left. Okay. Now we could technically draw another angle just like over here, and they would technically be terminal angles. But remember, what did we say we want to draw our angles in? Standard position. So we want to draw our coterminal angles in standard position as well. Does that make sense? Yes? So what would be a way then that we could still start on our positive x-axis and end up at the same spot?
Double it?
Not double it.
Like you go clockwise, or you could just add a 360.
Correct. So we could either go clockwise and end up at the same spot. Agreed? Okay. So how would we figure out what that one is?
360 minus
Not quite, because, I mean, you could, but what you would have to do after that is stick a negative on it. Because we're going the opposite direction, we show that by making it negative. So you could subtract it from 360, then you just need to make it negative. Or just subtract 360. And what do we get?
Negative 230 degrees.
Then our other option, if we wanted a positive coterminal angle, right, would be, how many of us have ever seen or participated in like skateboarding or snowboarding or surfing? Yes? There are tricks out there. Yes. So like a 360 is rotating what?
All the way around.
All the way around once. Agreed? What would it be to rotate all the way around once and then halfway around again?
540.
540. A 540 is to rotate fully around and then halfway around again, right? Which we get by adding 180. So we can keep rotating as many times as we want, and you would just keep adding 360, right? So 2 full rotations would be what? 720. Y'all with me? We can do the same thing on our angles. So I can start in the same spot, rotate all the way around once, and still end up at that same terminal side. So if I added a full rotation, what would we do to find the angle measurement? Not 130.
No, I mean 360.
Add 360. And what do we get?
490.
So how many coterminal angles could we potentially have? An infinite amount. So I could add or subtract 360 as many times as we want. Now, what would happen if I gave you an angle that was like negative 600 and I wanted a positive coterminal angle? What would I have to do?
Just keep adding 360.
Until you get to something that's positive, yeah. So sometimes you might have to add or subtract 360 a couple of times, depending on what it asks you to do. Are we all okay with that? Yes? Alright. So these are in what type of measurement? Degrees. Now we're going to talk about radians. So you need one person from your group to come get a piece of string if your group does not already have one.
Good hand, too.
And then you're going to need
Where'd it go?
Then you're going to need out one of the whiteboards and one of the dry erase markers from underneath your desk. So then you're going to draw a circle on your dry erase board. It needs to be pretty exact. So it might be helpful if you want, you can like tie the string to your dry erase marker, and then one of you can hold down the string, the other one can draw it around to make a pretty exact circle.
I guess we can half and put that.
Are you with me? So you just tie it to this.
And then if you hold
It needs to be pretty exact. That's what I said. Here.
Wow.
You tie that one to this. So I tie this to this, right? And one of them I do this, and the other one is so this is all the way around.
Oh, yeah.
You know, open a box, baby.
You can also use your ruler. Okay, so then you're going to plot. Then you're going to plot where your center is. And then you need to measure your radius. What is our radius? From the center to the edge. So like here, this would be a radius.
There we go.
That's
Radius is right in the there.
Yeah, so like this, put your marker there, and then so you're gonna measure your radius. Then you want to measure and mark off the same length on your string. So like if it was 2 inches, then I'm going to put my string on my ruler and I'm gonna mark 2 inches on my string. Choose your marker.
So we write on, we draw on the
You
string.
can draw on the string, yeah.
Draw 3. Or I.
So then what you're going to do is we're going to take the straight length of our radius and we're going to put that on the arc of our circle. And you want to mark off the same distance on the outside of your circle using your string. So like you're going to lie your string on the edge of the circle and mark where it would hit that same distance.
Oh, it's gonna end up being the same.
So if our string was 1 radius, right? And then we put it on our arc, what do we think that measurement is? 1 radian. Yes? So now I want you to find out how many radians are in your whole circle. So I want you to keep going and measure off
Oh, we keep
around the circle to figure out how many radians are in your circle.
This one?
Yeah.
Say we keep going like this. All the way down.
It's not going to be exact.
So
You're going to have some left over, which is okay.
2, 4,
You're going to have a little bit left over at the end.
like 6.5. Something like that. Right. Oh, yes.
So how many did we get?
A little bit above 6.
Yours was not long enough. You should get a little over 6. Agreed? So, in general, a radian is a measurement to the arc length of the circle. Does that kind of make sense? Y'all with me? Now, we said that how many degrees is in a full circle? 360. So it would be nice if we could also figure out how many radians are in a circle. Agreed? Because then we could kind of like convert between the two. Now, we said it's 6-point-ish, right? So what else do we know of that goes around the edge of a circle? Circumference. And what does circumference equal?
Radius.
2 pi r. Now, each of your radii were different lengths, correct? So we don't want to have to plug in all those different numbers. So what we're going to do instead is we're just going to say it's 1 unit. Okay? We're just going to say our radius was 1 unit long, which would give us that our circumference is what? 2 pi. Well, what is pi approximately? 3.14 times 2 gives us
6.28.
28, which is a little over 6. Which is why we have 6 and a little left over radians and 1 full rotation. Now, most of the time, we're going to leave our radians exact. We'll say 2 pi, because we don't want to get the decimal approximation, so we'll leave it exact. Now, that means that 1 rotation is 2 pi. So what is a half of a rotation? Just pi. What about a fourth of a rotation? A half pi, the way that we usually write that is pi. What's about pi? Pi over 2. Yes? So what does that mean that pi is equivalent to?
180.
180. And what is pi over 2 equivalent to? 90. So when we convert between degrees and radians, okay, notice that 2 pi equals 360. Agreed? But both of those can be reduced by 2. So in general, we're going to use this second one, that pi equals 180 degrees, when we want to convert back and forth between the two. So hopefully we've done some conversion rates in some of our science classes, like converting units. Like if you needed to go from miles to meters, or like if you have to go from hours to minutes, right? You're just converting. Same thing here. We have a conversion rate, and it's either going to be pi over 180 or 180 over pi. And whichever unit we're trying to get rid of is the one that goes on the bottom. So if I'm trying to convert from from degrees, I put degrees in the bottom. If I'm trying to convert from radians, I put radians in the bottom. So let's do some examples. So if I have 135 degrees and I want to switch to radians, what do I want to multiply by? Pi over 180. Now, since all of these are in degrees, I'm going to multiply by the same thing. I want my 180 degrees to be in the bottom because that way our degrees reduce out. So notice that if I have degrees in the bottom and in the top, they reduce with each other, which is why my degrees go away, and we just end up with radians. Now, we don't generally put a unit symbol next to things that are in radians. So we actually put the little hollow circle to mean degrees. For our radians, because we're relating the radius, right, which we just said was 1 unit, there's not an actual, unit with it. We call it a pure measurement because it just relates things that are rotating, which is why sometimes it's better to use radians than our degrees, because degrees are like a man-made measurement, so we can only get so small with a degree. Does that make sense? You have minutes and seconds within a degree, so that's really as small as you can get. However, when you're talking about things rotating and you need them to be really, really, really precise, like for propellers, or when you're launching things like spaceships at specific angles, most of the time you're going to use radians because you can get 0.2597 of a radian, and you can get really, really exact with it. So that's why they are out there. Then after I reduce my degrees, from there it's just reducing fractions. So how many times, or what goes into both 135 and 180? So 5. What would be left over if I divide both of those by 5? You might want to get out a calculator. 27 and 36. What goes into both of those? 9. So what does that mean if 5 and 9 go into both of them? What goes into overall? 45. So what's 135 divided by 45?
3.
And 180 divided by 45? 4. So we end up with 3 times pi. So we're just going to put 3 pi, and then we have a 4 in the bottom. And again, we want to leave the pi there because we don't want to write a long ugly decimal. Now, what about 540 and 180?
180.
Okay, how many times does 180 go into itself? 1.
Yeah.
How many times does it go into 540?
3.
3. So what do we end up with? 3 pi. And then what goes into both 270 and 180? 90. And so it goes into 180 twice and 270 3 times. But what do we have to worry about with that last one?
The negative sign.
It's negative. So basically we just end up sticking that on the front. It doesn't change it a whole lot. What does the negative symbol tell us? Correct. It goes clockwise instead of counterclockwise. And even if you're in radians, that's the same thing. Okay, it's just telling us what direction it goes. Yes. Alright. So then we can go the opposite direction. What am I going to multiply these ones by?
180 over
180 over
pi.
pi this time. Because we're wanting our pi's, or our radians, to be what reduces. So it goes on bottom. So notice that my pi's reduce in my first two. I don't have a pi to reduce in my last one, but we'll get to that in a second. So then how many times does 2 go into 180? 90 times. So we end up with negative 90 degrees. Again, how many times does 2 go into 180? 90. So then we have 90 times 9, which gives us 810 degrees. Now, in my last one, do we have anything that reduces? No. My pi's don't reduce. I don't have anything in the bottom of my fraction. So we would just do 2 times 180 gives us 360 degrees. And this is a time, because we're in degrees, we would want to get a decimal approximation. So you would plug this one in to your calculator and do 360 divided by pi. And what do we get? $114.591559 degrees. Now, if there was a pi with it, what would 2 pi equal?
Double that.
No, not double. That would just be if it was 4.
It would be a full rotation.
Which would be full rotation, which is 360. So if there was a pi with it, right, our pi's would reduce, so then there would be 2 times 180, which is 360. But because we didn't have that pi to reduce, that's why we end up with the weird just 114. Which makes sense because notice, maybe, on my circle, right, this was 1 radian. My second radian is into my second quadrant, but not quite halfway. So this is probably a little bit bigger than it should be. But so that kind of makes sense that 2 radians would be like 114. Alright. Then, lastly, for today, we're going to look at some things with our radian angles. Please do not get in the bad habit of just wanting to convert everything to degrees, okay? Radians will take practice. A lot of y'all have not dealt very much with radians, so if they just don't come like super fast for you right at first, that's okay. They take practice. But if you just keep converting everything back to degrees, you're not going to get the practice with them. And eventually we'll get to problems that are long enough that you don't want to like waste time just converting back and forth between radians and degrees. So when we're looking at these, they ask us to find coterminal angles. When we had degrees, how did we find coterminal angles? What did we do?
We subtracted and added, please.
Correct, which is the same thing as what in radians? 2 pi. So we would add or subtract 2 pi in order to find a coterminal angle. Are you okay with that? We have a fraction here, right? So how do we add things that are fractions together?
They have to be the same denominator.
Correct. Does our 2 pi have the same denominator as my 13 pi over 6? No. So what would we do?
Multiply by 6.
Multiply by 6. Just 6?
No. No.
So how do I make my 1 in my denominator a 6? If I just multiply by 6, I would get 12 pi.
You have to multiply that denominator by 6 to do that.
Correct. I need to multiply by 6 over 6. Because then I didn't technically change the value of it, I just changed the way it looks. And then what does that equal? 25 pi over 6. Now, if I subtract, do I still need to convert to the same denominator?
Yeah.
Yeah. This time my common denominator is going to be 4. So my 2 pi would become 8 pi over 4. So we end up with negative 5 pi over 4. And then on our last one, if I wanted to add 2 pi, I would get 6 pi over 3, which gives us or pi.
Does it matter if we subtract or add?
No, sometimes it might tell you, like, find a positive coterminal angle or find a negative coterminal angle.
Yeah.
This one just said, this is a positive angle, this is a positive angle, this is a negative
So
angle, and
you
just asked us to find one. So you could do either one. Other questions?
It's always gonna be plus or minus 2 pi, right?
If it's a coterminal angle. If they ask you to do other things, then it could be something different. But for coterminal angles, it's always 2 pi. Yes.
So like general formula would be like plus 2 pi in, where n is any integer.
Pi.
And then times any integer. And that'll always give you a coterminal angle.
Yeah, if you needed to find more than one. It could be, yeah, so like the n would mean it could be positive or negative, yes. Other questions? Alright, so we're gonna stop for today.